Okay, now that we've kind of looked at solubility and what it means to dissolve, we're going to look at how we can calculate the concentration of a solution. So, a little review of saturation. We have saturated, unsaturated, and supersaturated. These are our terms to describe solutions. But these do not allow solutions to be compared quantitatively, meaning using numbers, right? They just tell us whether it's at its max, above its max, or below. Okay, and since that max is different for every substance, it doesn't really allow us to compare them. It's like saying a material is heavy or light. There are no numbers to back up those claims, just your observation. So something that's heavy to me might be light to someone else. And something that's supersaturated for one solution is unsaturated for another solution. So we really need numbers to be able to compare solutions to one another. There are many different methods to calculate to calculate concentration. Each method is valid and has its own use. The most common one is molarity, so that's where we'll start. We've also got parts per million, parts per billion, molality, and a couple others that we will talk about. Now, molarity. Notice it has the term mole in it, which means we're going to use moles. And what we look at is how many moles is dissolved to make how much solution. So the calculation for this is moles of solute, remember that's the thing being dissolved, divided by liters of total solution. So not liters of your solvent, it's liters of solution that you make. And that equals our molarity, which is has the units capital M. So that is not meters, it is a capital M, meaning molarity. Now to review, we need to convert grams to moles. We divide by the molar mass. And 1,000 milliliters equals 1 liter. So if we see like 2,000 milliliters as our liters of solution, we would know that that is actually equal to 2 liters. So an example here, what is the molarity of a 3,000 milliliter solution made using 25.23 grams of CaCl2? Now we're going to go back to our stoichiometry here and our dimensional analysis to convert grams to moles. So we've got our 25.23 grams of CaCl2. We calculate our molar mass, and that goes on the bottom, 110.98 grams of CaCl2 and 1 mole of CaCl2 on the top. Okay, we do our math and we get 0.22733 moles of CaCl2. Now, we don't want to round that number. We want to wait until the very end. And we're going to use that along with our knowledge that 3,000 milliliters would equal 3 liters. We're going to divide our moles by our liters, and we get 0.0758 molarity solution. Okay, so that would be our final answer, and that would be the answer where we finally round to however many digits it tells us to round to. Now, this was one example of how to use our molarity calculations, okay? But we can use these calculations to solve for moles, for liters, and for molarity, right? So we can rearrange this equation to do all sorts of problems, okay? Now we're going to take a look at parts per billion and parts per million. This is kind of what it sounds. If the solution is a billion or a million parts, how many of those are the solute? So if we have 10 parts are our solute and we have 1 million parts, that would be a 10 parts per million substance. Likewise, if we have 10 parts solute and 1 billion parts overall, that would be a 10 parts per billion solution. These are easier to calculate because there's kind of less converting. It's important that your top and bottom must be the same unit. So if we're talking 10 parts, like 10 grams, then we need to have 1 billion grams of solution. If we're talking 10 parts, 10 milliliters, then we need to have 1 million or 1 billion milliliters. So an example here, if you make a solution that is 290 drops of lemon juice and 710 drops of water, what is the concentration in parts per million? Okay, so we have 290 drops of solute, right? That's our lemon juice, and we have 1,000 total drops of solution. So that's our lemon juice plus our water. And we would times that by 1 million because we are looking at parts per million. And we would get 290,000 parts per million of a lemon juice. Okay. Another way we can show is percent composition. So this is what percent of the whole is the solute. It's important that both solute and solution are measured in the same units, just like in parts per billion or parts per million. But this could be presented by volume, where the top and the bottom, the solute and the solution, solute and solution are both measured in milliliters or liters or some sort of volume measurement. Or it could be percent by mass, where we're measuring in grams. Grams per liters or grams per milliliters, grams per microliters, kind of any division of a liter, is another frequent way to measure concentration. This is not such a great way to measure for comparison between substances, because as we talked about back in our last unit, we saw that grams are not comparable from one substance to another. So a certain, 10 grams per liter solution of one substance isn't necessarily the same concentration as 10 grams per liter of another substance. Okay, so we're going to go through some practice calculating different types of solutions, specifically with those molarity calculations. So if you're confused by those, make sure you go back and take a look at how we did those again. Reach out for to your teacher if you have questions. Otherwise, go ahead and move on to your practice.